Section 1.3, Determining Limits Using Algebraic Manipulation. First step in finding a limit is to simply, logically, if you can, if it's easy, you want to find f of 4. What I mean by that is you want to put 4 into the function. Because if you plug it in and it gets an answer, you're done. You don't have to do anything else. Now, that's going to take a while on this, and I'll tell you, it's not going to work. It's going to be undefined. You're going to get a 0 on the bottom. What's going to happen here, you're going to get a 0 down here and then something up here, and it's going to have an error. So we're going to go, okay, I'm just telling you that. But that's the first thing you do, because sometimes all you have to do is simply plug in the 4, and it works. It's not. So here we go. The next step we're going to do, when that doesn't work, is we want to factor top and bottom and see if we can eliminate something and reduce it and simplify it. So by doing that, I'm going to take the limit as x approaches 4, and I'm going to try to reduce the top and the bottom. So from the top, what I notice is I can pull out a 6, and I can pull out an x squared as a GCF. That leaves me x minus 4. Okay, so that's the top. And on the bottom, if I look at it carefully, I can pull out a 2 and an x. That would leave me a 4 minus x. All right, so when I look at that, I can see, okay, this will cross out with this, and these two reduce to 3 over 1. So what I now have is the limit as x approaches 4 of, we have a 3 on top, an x on top, and x minus 4 on top. And on bottom, we have a 1, and I want to do something here. This right here looks so much like that. If I pull a negative 1 out of this, won't it match this? And yes, it will. So I'm going to do that. That'll help me. Watch what happens. I'm going to pull a negative out, leaving me a negative 4 plus x. And what you'll notice is these are identical if you rewrite them. So what I can now do is these disappear, leaving me the limit as x approaches 4 of negative 3x. I now have a simplified version of this. Okay, this is this nice simplified version. Now, if I plug in 4 to this, I'll have my limit. So I can now do it very easily. So now I plug in 4, and I get an answer of negative 12. What does that mean? The answer to this is negative 12. So this function, as you approach 4 from both sides, gets closer and closer to negative 12. If you plugged in 4 to the original, it wouldn't make sense. But it does make sense once you simplify it. Alrighty, so let's take this limit. First thing in all limits is to, right off the bat, try to do f of 5/3. And if you try doing that, that's going to be a nightmare. In the end, I'll just tell you, it becomes something over 0, which means you can't. But if it did plug in nicely, it would have been a lot easier than the process I'm about to show you. So we are now going to simplify top and bottom here so we can then hopefully plug in 5 over 3 and find an answer. So what we're going to do first is the factoring. So the limit as x approaches 5/3 to start with. The top, what I notice here is I'm going to pull out a negative 1 and make this 9x squared minus 25. All right, I pulled a negative 1 out and flip-flopped it. The bottom, I'm going to factor, and I'm going to use a little factoring technique where I take the front and the back, I multiply them. That's 45, negative 14 on the bottom. I'm now thinking of two numbers that multiply to get 45 and add or subtract to get negative 14, add to get negative 14. So what I notice here is that's negative 9 and negative 5. So when I do that, that leaves me a 3x squared minus 9x minus 5x plus 15. Now how do you get all that? Well, I kept the front and the back, and I changed negative 14x to be a negative 9x minus negative 5x. So I just changed the middle. And then you're going to do a grouping method, which you're going to pull out a GCF out of the first pair. That leaves you this. And then I'm going to pull a GCF of negative 5 out of the second pair, and that's going to leave you this. And once I do that, these match, so it's going to be x minus 3, and then you take these two pieces, are the leftovers, 3x minus 5. So that doesn't help me. Nothing crosses out quite yet. So what I'm going to do is, I notice the top can still factor, so let's keep working on this. Factoring, hopefully you're good at factoring. It's all based on factoring, so you got to be good at it. The top is a difference of squares. Hopefully you notice that's 3x squared, and this right here is 5 squared. So the difference of squares factors as 3x minus 5, 3x plus 5, and the bottom is still the x minus 3, 3x minus 5. Now what I notice here is, looks like these disappear. Leave me a new limit, a lot of work here, you'll be okay. The top is now -1, 3x plus 5, and the bottom is x minus 3. Now what we're going to do is we're going to now try to plug in, 5/3 and see if it comes out nice. And it will. It will come out nice, but it will actually work. So when we do that, we have -1 times 3 times 5/3 plus 5, that's the top. And the bottom we have 5/3 minus 3. Okay, a little ugly, huh? Sorry about that. So what we have, these 3's disappear. 5 plus 5 is 10, so this right here is -10 on top. And on the bottom we have 5/3 minus, and we have to do 3, so we have to multiply, that's over 1, so we're going to multiply top and bottom by 3. So what I now have here is, it looks like, I'm going to come over here, I have -10 over 5/3 minus 9/3. Okay, so that becomes -10 divided by -4/3. And when you divide, you flip and multiply, so that becomes times a -3/4. All right, you can put a 1 down there. If you want to, this reduces with this to be a 2 and a 5. Don't forget that negative. So this becomes, multiply the top, you got positive, I'm going to put -15 over 2. So that is the answer. So my answer, let's put it up here, is 15 over 2 is the answer to this. A lot of work there to find the limit.